I hope by undertaking research focusing in sustainable development, we will be able to create change as part of a continuous improvement process.
Recognize the work of healthcare and life science scientists and organizations who contribute to innovative healthcare solutions.
I hope participants will continue their efforts in showcasing their hard work, find a product, and meet potential partners.
We are growing too fast. We walk fast. We eat fast. Though we have 24 hours in a day, somehow we share the same feelings. Time is passing so fast. We don't have enough time for ourselves until busy is the new norm in our life. But if you can turn back the clock, what good shall you do today? Let's put life back. We need the past to enlighten the present and the future. We need education. Through education, it reconnects you with the purpose of life. Reconnect with family and people. Reconnect with nature and habitat. Reconnect with unity and harmony. Reconnect with spirituality and peace.
اقرأ باسم ربك الذي خلق.
Reconnect with good health and well-being. To create balance, UITM nurtures Buddhi in education and embraced it as values in life. A concept of social relationships. A philosophy and culture of politeness, reasoning and wisdom among Malaysians. UITM upholds Buddhi for sustainable community. Education reconnects you with the universe. Reconnect your world with UITM.
In the quest to search for knowledge and insights, diving deep for ideas to gain prominence, be they the scientists, teachers, accountants, entrepreneurs, engineers, artists, managers, lifesavers, mothers and fathers. Let us be a trusted companion, your preferred high-flying institution, as we achieve excellence holistically. Because we believe in nurturing our future talents, we endure sowing the seeds for a sustainable tomorrow. We harness your capabilities. We take steps and stances to broaden our knowledge and experience. We want to be the champion to uphold mankind's universal values, to encourage a deeper understanding of sustainability. We dare to be different. We instill values. We cherish the diversity, where science and arts complement each other. We go boldly. Set the scene. Steal the show. Think out of the box and set our sights. Walk far and wide. We dedicate ourselves to all our passion, to nurture the courage in all of us. We lead.
UCSI University has come a long way since 1986 as a Praxis University. Today, UCSI is ranked at the top 300 university in the world, rising steadily every year, reaching the rank of 284 in the year 2023. In the same year, UCSI became the only university in the world to receive the QS Recognition for Improvement Award, having improved by the most ranks in average. UCSI programs are ranked among the world's best in music and performing arts, hospitality, engineering, business management, art and design, social sciences, and medicine. As a Praxis University, our students are exposed to a wide learning experience. Thousands of corporate partners offer internship and work exposure to UCSI every year, enabling our students to apply what they learned in the classrooms to be practiced at the workplace. They give the students opportunities to work and learn. This resulted in our graduates attaining 100% employability score in all our programs. One of the hallmarks of being a UCSI student is the research attachment opportunity at world-leading universities at the undergraduate level, enabling them to publicize remarkable papers at the world stage. opportunity to study abroad, whether for a year or two, or for a short term of a few months, prepare our students the global outlook that the world needs today. Preparing as leaders for tomorrow. The students are exposed to real leaders today, from academics and economics, to social concern and topics on sustainability. Our students are set for the challenges today and the future. UCSI offers the largest fields of study in a Malaysian private university, whether in championing healthcare and medicine and pharmacy, impacting research and discoveries in applied sciences, applying skills and intelligence in engineering, influencing communication in social sciences, igniting the passion and creativity in arts and design, setting the global pace in hospitality and tourism, transforming architecture and built environment, celebrating with music and performance, excelling in the changing demand of the business world, or digitizing the world in computing and innovation. UCSI continues to serve with scholarships, producing tens of thousands of practitioners and young leaders from more than 110 nationalities. Beside its current main campus in Kuala Lumpur, and other campuses in Kuching and Spring Hill, UCSI has earmarked its Kuala Lumpur campus to expand as an edu city with 35,000 student capacity with various state-of-the-art facilities. Our students are the real stars of UCSI. They achieve and excel in the national and international stage. Driven with the passion to contribute, they prove their quality, participating in various events and attaining many successes. UCSI enables them to make the mark for themselves, build their own reputation, and create a brand for themselves to face the exciting world ahead of them. Every year, our medical students advance their undergraduate medical research at the Harvard Medical School. Others made the engineering impact at the Imperial College London, at Queensland, Australia, and Tsinghua, China. While some set their pharmaceutical legacy at University of Chicago and British Columbia. These are some of our students who have benefited from our Star Trek to the world's best universities. The world is changing, and they are at the forefront. The needs are evolving, we continuously confront. UCSI, a Praxis University.
Ladies and gentlemen, welcome to our knowledge sharing session. We hope you'll enjoy the next webinar. Thank you for joining us.
We are all well aware that water is a valuable resource to ensure the sustenance of mankind. And Malaysia is blessed with abundant water through ample rainfall. But if we are not careful, we may lose this irreplaceable gift. But what if we told you that Indah Water Consortium IWK Sdn Bhd, the national sewerage company, can provide an alternative non-potable water source to alleviate the burden of our raw water resources? And IWK is gradually advancing this agenda. Branching out from the traditional sewerage utility shell, IWK adopts a waste-to-wealth approach to support the sustainable water management agenda. IWK aspires to achieve the United Nations Sustainable Development Goals (UN SDG), particularly Goal 6, Clean Water and Sanitation, through the implementation of the Green Technology Master Plan GTMP 2017-2030 that focuses on resource recovery efforts. As such, IWK adopts green technology to convert byproducts from wastewater treatment processes into value-added, sustainable and reusable products, namely bioeffluent, biosolids and biogas. The reuse of byproducts are aligned with the GTMP's main focus of reusing 33% bioeffluent and 100% biosolids. This is also a shared strategic direction by the Ministry of Environment and Water (KASA), known as Environmental Sustainability Malaysia 2020-2030, which aims to produce 1,500 mld of reclaimed water from treated effluents. In this regard, IWK reuses one of its byproducts, namely the bioeffluent, as an alternative source of non-potable water through the Reclaimed Water Initiative. This initiative involves further treatment of the existing treated effluent produced from IWK's sewage treatment plant (SDP) through a modern technological process at the Water Reclamation Plant (WRP), which is specially built near IWK's SDP. IWK embarked on a strategic joint venture with Pengurusan Air Selangor Sendirian Berhad Air Selangor to advance this initiative. Through Central Water Reclamation Sendirian Berhad, Central Water, a special purpose vehicle SPV company, the bioeffluent treated at IWK's treatment plant will be further treated at Central Water's reclamation plant that is equipped with advanced technologies to produce non-potable reclaimed water that can be safely used for industrial purposes. Let us dive into the details of how the Reclaim Water initiative works. Central Water's WRP is located in the Regional Sewage Treatment Plant RSTP Petaling at Setia Alam 1 Shah Alam, Selangor. The current capacity of the plant is 4 MLD and will tune up to 7.5 MLD per day after upgrading works. The treatment technologies that Central Water employs include pre-treatment, ultrafiltration or UF, and reverse osmosis or RO. Upon completion of the treatment process, the water is channeled through dedicated distribution pipes before being distributed to industrial end users. The first process is the pre-treatment process. In this pre-treatment process, the treated effluent is channeled through an auto strainer that sieves through coarse particles that may damage the UF filter membranes. When the strainer is blocked by particles, its pressure will build up and will be detected by the system to initiate a backwash process. The backwash reject water is discharged back into treatment works for processing. The filtrate will be delivered to the UF feed storage tank. The storage tank provides a buffer capacity to ensure smooth operation of downstream UF filtration process. The second process is ultrafiltration process. The UF filter can filter up to 1 micron of particles. Particles larger than the permitted size are retained at the UF membrane surface. The UF operates in a cross-flow manner that enables some of the liquid to flush out the retained particles on UF membrane and discharge the water back for treatment works. Other portion of the feed liquid is filtered through the membrane to produce clean UF product water. This UF product water is also stored in the UF product storage tank to ensure smooth operation when the UF is put into backwash mode. In order to ensure smoother operation of the downstream process, 2 banks of UF filtration is operated in parallel. If one unit is out of service for backwashing, the other UF filtration system will still produce UF product water. The last process is the reverse osmosis process. In this process, a very fine membrane is adopted to allow only water molecules to pass through the membrane under high pressure in a RO process. Due to the fact that only water molecules are able to seep through the membrane, an RO membrane will filter solute particles in liquid. Particles that are retained on the surface of the membrane is flushed out during the filtration process and discharged back for treatment works. Water that permeates through the RO membrane is collected as permeate water and stored in RO permeate storage tank. When the treated effluent has undergone all these processes, the final product is distributed to industries for non-potable use. This intricate process ensures that drinking water quality can be used for better purposes instead. The clean water or RO water in WRP that Central Water produces benefits the states and our country as we move towards the circular economy agenda. If you have any further questions or require additional information, kindly visit our website at www.iwk.com.my or visit our Facebook page at www.facebook.com/Indah Water Consortium. Thank you for tuning in to our Water Reclamation Plant virtual tour. Hope to see you again and stay safe.
Welcome back, ladies and gentlemen. I hope all of you have enjoyed this virtual site tour, and I would like to thank IWK for this informative and interesting presentation. Indeed, this collaboration between IWK and Selangor is timely and will definitely open up opportunities for water operators to obtain alternative water sources for non-potable purposes, which in turn can contribute towards maintaining the country's clean water resources and reducing pressure on water sources, thus increasing circular economy practices. Ladies and gentlemen, now I would like to open the floor for the Q&A session. Before I proceed, let me first introduce the panelists from Indah Water Consortium who will be attending to your questions shortly. We have Mr. Azwan Zahdi, the General Manager of Corporate Planning Department. Azwan has over 15 years of consolidated experience in corporate transformation, strategic planning, business development, and sustainability. He is responsible in ensuring strategies are comprehensive in meeting the aspirations and vision of the company. Prior to IWK, Azwan has served in similar roles in automotive, water, and aviation industry. Okay, and we also have on board Mr. Jason Ng Chan Hin, the Manager of Planning and Engineering Department. Jason Ng is currently the Manager of Process Design Unit of Planning and Engineering Department at IWK. His experience covers from planning, engineering and design, construction, and operations and maintenance of sewage treatment plants. Jason has short experience in O&M of ultrafiltration system and now involved in reclamation project of bioeffluent via UFRO system for non-potable industrial usage. That was some short bio of the panelists. You may key in your questions in the chat box and I will read out the question to the panelists. Okay, all right, we have the first question coming from Mr. Eddie Wong. What is the life cycle cost for per meter cubic of recycled water at the plant now?
Mr. Eddie, the life cycle cost for us, including sinking fund, all these things, is approximately about $2.20 plus.
Okay, while waiting for questions coming in, let me ask another question I do have here. We know that Malaysian domestic water supply tariff is highly subsidized by the government, and it is expected that the cost for this capital and operation and maintenance of this high-tech WRP should be higher than the commercial water tariff. Like you said earlier, Mr. Jason, the cost, the tariff is RM2.20, right?
Yeah, correct.
Okay, how much is this tariff compared to the reclaim water, for this reclaim water as compared to the commercial tariff?
Commercial tariff depends on the countries, depends on the state. Some of the state is RM2.70 per meter cube, whereas some of the state is RM2.15 or 20 cents per meter cube. So depends on the state.
What I mean is, before you adopt this WRP for this particular STP, for this assigned STP in Setia Alam, what was the cost of commercial tariff?
Commercial tariff for
this plant. Have you sold any to any factory before?
Prior
to this WRP?
Maybe in Azwan, but yeah, no. Sure. Yeah.
Go ahead, Jason.
Yeah, for industrial use, we are using for washing purpose. Yes, those are very low cost because from the bioeffluent directly for washing for water plant to the Majlis, those are relatively low cost. I don't have the exact figure for the cost, but it's very low because those are not going through the UFRO high-tech, where high-tech, not only high-tech, but high energy cost for the treatment.
Well, thank you, Jason. If I can add a bit, Puan Miraya. when we come up with this water reclamation plant model, we have to also take into consideration the various factors, both financial as well for all parties involved. So in order for this to work, as you rightfully said, that it involves quite a significant investment cost. And for us to be able to produce to a certain quality of reclaimed water, the model has it that in a way that it has to be cost recovery. So meaning to say that, as what Jason said, depending on the end customer, it's a case-to-case basis that we approach it together with our partner. In this case, is Air Selangor. So we must ensure that what kind of quality that the off-taker is talking about, and we factor in all this consideration and ensure that the final product that is being produced to the end customer will be able to be something that is for them to see the value out of it. So when we mention the value, it's not just about the absolute price of the water, but at the same time the quality of the water. So we put all these variables into the equation, and we'll be able to see to come up with a collaboration with the water operator as well as with the end customer.
But if I may ask, what is the capital investment for the WRP, and how long is the ROI?
Well, it depends on project to project, but this particular Setia Alam punya project is there's an amount to it. It's about it's about 12 million in totality. However, it involves different phases and different components as well. And in order for us to be able to recover that particular cost, of course, the tariff need to be sustainable. At the same time, we're talking about the volume that the particular plant can produce for the end customer.
Okay, thank you, Mr. Azwan. We have a few other questions from the floor here. We have questions from Syed Shafiq. What is the overall price? What is the overall price of the treatment system and operating costs? This is like how we mentioned earlier.
Yeah, just now Azwan already mentioned that the cost for the capital is about 12 million because these are our first project. And then the operation costs, we come up, including the replacement part of the membrane, all these things come up will be close to 2 ringgit per meter cube, including manpower, chemicals. Again, these depends on the customer requirements. Some of the customer require higher spec and post-treatment, then the cost will be slightly different. We are at this moment 2 ringgit is without the post-treatment.
Yeah.
Without the post-treatment, okay.
Yeah, without post-treatment. That means after RO.
After RO, okay. Not including the distribution, yeah?
Yeah, inclusive of distribution, yes.
Okay. We have another question here from Nafisa Rahiman. Currently, what kind of industry uses the reclaimed water?
I think the industries that we have been approaching is those, obviously it has to be non-potable usage, nothing to do with food and beverage industry. And of course, those industries that require a specific kind of quality in terms of what reclaimed water can offer. So particularly if you're looking at our plant from the video that we saw just now, our first customer is actually from the rubber glove manufacturing company. So it's a very attractive kind of customers that we are also talking to some of other industries as well. And it also one part of the equation on who are the potential customer that we are looking at next. So in particularly, as I mentioned earlier, what kind of quality, what kind of volume, and also those that are also located not too far from our existing plants. So these are some of the variables that we have to take into consideration. We do receive quite a bit of requests from different industries. However, it has to go back to the suitability and also the availability of our bioeffluent at the same time.
Okay, thank you. Syed Shafiq asks, how can you sell it? It is higher price than Air Selangor. Might as well they take from Air Selangor. So like I asked Mr. Jason earlier. So what is the difference between the reclaim water tariff and also the commercial tariff. So it should be slightly lower than the commercial, right? I suppose.
Well, that's a fair assumption lah. I mean, a lot of people will say that I might as well get it from the water operator lah. Assuming that it's other parts of Malaysia as well, so it could be with other water operators. So rather than going through this getting reclaimed water, we might as well get it straight from the water operators. But there are other factors to it also. One is in terms of the quality of the water. So some of the people that we approach to, or people have been approaching us as well, wanting a specific kind of quality that is more towards that favors towards whatever processes that they are going through at the factories. So they say that by taking reclaimed water, it's more the kind of further treatment or usage would be easier for them. So that's one in terms of suitability to the particular process. Number two, also some of the industries are also looking at in terms of alternative supply, in terms of having two sources of water. So not to say that the particular industry taking from reclaimed water will completely shut off the tap that is coming from the normal water operator, but it is another stream of supply of water for them. So this is very important in terms of sustainability of their operation as well.
Okay. We have a bit of technical question over here. Why the final retained from RO being channeled to STP and not directly returned to the water reclamation intake point? Because normally the retained quality is equivalent or better than the final effluent quality from the STP.
Okay, not really, because there are many different processes. There are pre-treatment, then there's a UF, and eventually there's a RO. For the pre-treatment, we are filtering the large particle. Those cannot go back to the water industry, water reclamation plant, so have to discharge back to the treatment works for further treatment. Same thing as a UF. You are filtering the large particle to a smaller size, but then it's still a lot of particle, and this reject go back to the treatment works. Now, the RO water quality depends on the number of stages of the RO water quality. So if the higher the stage of the water RO treatment system, the reject water got, let's say if you are 75% recovery, that means there's the concentrate of the retentate is about 4 times of the solute coming in. So therefore, it is best to actually go back to treatment works rather than recycle, because the membrane is used to remove solute, whereas this solute is actually become concentrate 4 times to 5 times. So therefore, it's much beneficial to actually discharge back to treatment work rather than to recycle back to the water. It's not so straightforward, because the higher the concentration, the pressure, the osmotic pressure become higher, energy become higher. So best is actually to return back to the treatment works.
Okay, I see. Okay, we have question number 7 here from Ms. Loy. What are the components of sewage effluent which needs to be removed to qualify it as reclaimed water?
Okay, of course, first one is BOD, COD, suspended solid. Those are basic required to remove. Whereas ammonia, ammonia is also part of the important that we need to remove in order to go back to, because the RO membrane, if it is in the gas phase, it will not be removed by the UF as well as RO. So therefore, ammonia become a critical important need to be removed at the treatment plant works. So if the RO itself, even though it's in gas phase, it will pass through the RO. So that's best is actually do in a wastewater treatment plant. So
it
those
is
are
the parameters. It is actually the parameters quite the same as effluent discharge, right? The normal effluent discharge of the treatment plant. It's just that WRP has more stringent requirement. Am I right?
In terms of suspended solid, yes, suspended solid is very important. So therefore, we have to have a pre-treatment. Either you can use a strainer, fine strainer, or you can use filter cartridges, all these things to remove to much lower, what do you call that, suspended solid, very low suspended solid. We classify as what you call turbidity, very low turbidity before you go into the UF. Of course, RO, it has to be very low.
All right. Okay, question number 8 we have here from Baria. For feed water of UF system, for feed water of the ultrafiltration system, what is the limit of turbidity? As I know wastewater have high turbidity. Is the need the pre-treatment before enter UF?
Oh yeah, that's why I say that. Yeah, this is the same question, question, previous one. You need to have a pre-treatment to remove all the suspended solid. So because that's the only thing that you can, UF is actually also remove suspended solid, whereas RO removes solute system, where it's dissolved in the water. UF and pre-treatment system is very important to remove all the suspended solid, especially microorganisms, so that it won't be attached to the membrane system. So therefore, pre-treatment is very critical in the reclaim of bioeffluent.
For this particular WRP, the UF is up to 1 micron, right?
Well, it can depends on the pore size. You can go lower than lower than 1 micron. You can go to 0.1 to 0.1 micron. Today, technology can go to 0.1. Of course, the lower it is, the more energy you use, the more backward you use, the more wastage. What do you call that? The recovery will become lower and lower. The higher the quality is. So you have to trade balance of what it all depends on customer. What some of the customer require very low total dissolved solid, TDS. So therefore, then it become more expensive.
Okay. So this has been agreed with the, I think has been agreed with the factory,
end
right?
User.
With the
End
factory,
user, yeah.
Okay. Right. Next one, the question number 9 from Eddie Wong. What is the chlorine demand for the treated recycled water?
Treated recycled water, that means coming out from the sewage treatment plant. Yeah, we are those
from RWRP. Demand for the treated recycled water.
Now, there are few dosing that we require to put in. One is actually pre-treatment. Then after that, of course, in the backwashing, you also treat in the UF. But RO, you cannot have chlorine, because you have chlorine, you will damage the membrane. Even 1%, even 1 ppm of the membrane, 1 ppm of chlorine, you will damage the membrane. Therefore, you don't dose any chlorine for the pre-treatment of RO membrane. But after RO membrane, the dosing we maintain. In principle, you don't have to dose in chlorine, but because of the storage, all these things, we still dose it about 2 ppm to maintain about 2 ppm.
No wonder I noticed that there is no disinfection process involved from pre-treatment, ultrafiltration, and later to reverse osmosis.
Yeah,
so because it will damage the RO, yeah?
Yeah, correct. So RO, therefore we have to dose in this sodium bisulfite to dechlorine before it go into the membrane.
Okay. Okay, the next one from CLE. May I know whether dedicated pipe network is part of the project cost or is Air Selangor CapEx?
If I can take this question, usually based on our current model, that this will be under the water operators CapEx cost.
Okay.
It will be separate from the WRP cost.
Oh, the distribution pipe, you mean is separated from the construction of WRP?
Yeah, correct.
Yeah, it depends on the distance and the pressure. The longer the distance is, then the more capex and also higher pressure. So this part is actually variable.
Okay. In this,
Yeah.
in the distribution piping to the factory, do you adopt the pumping system, force main or by gravity? And what is the reclaimed water storage capacity provided in this WRP?
First, the two questions. The first one, yes. So far, you have to use force main. You have to use pumping so that you can maintain at the end of the customer site. We provide about 2 bar, which is about 20 meters. Now, the second question is whether
water storage
the storage capacity required. In our case, we have around almost 10 hours to 12 hours of storage capacity.
I see. Okay, the next questions we have here. Hi, Encik Azwan. What will be the OPEX for this reclaim plant? From David Ong. And how frequent do you expect for membrane replacement?
Hi, Mr. David. I'll take the first part of the question. What will be the OPEX for this reclaim plant? Unfortunately, I will not be able to reveal it without putting myself into trouble. Of course, there's a legality of an ongoing project. So, however, in ballpark figure, roughly as my colleague Jason has mentioned, is roughly around 2 ringgit-ish. We're talking about that particular OPEX for a typical reclaim plant this size. The second part of the question, I guess, Jason, if you can help me in answering this.
Yeah. The second part, what was the question again? Can you repeat?
How frequent do you expect for membrane replacement?
There's 2 parts of membrane. One is UF and one is RO membrane. The lifespan of the UF system, it will be shorter, roughly around 3 years, because you are directly deal with the microorganism of fouling. Whereas the RO part, it can be slightly longer, 3 years to a maximum of 5 years.
3 to 5 years. What are the strategies or plan of the central water reclamation, Sdn Bhd, to continue increase this WRP production capacity to 7.5 MLD in the future? At the moment, it is taking 5 MLD, right?
About 4 MLD.
4 MLD, okay. But it's looking towards producing capacity up to 7.5, right?
Correct.
And what is the strategies or plan taken by this CWR to continue to increase this WRP production?
The strategy, I think Encik Azwan, better you explain the strategy.
Well, I think the demand has always been there in terms of course, given the chance, we don't mind doing 7.5 on day one. However, we believe that by doing it in phased approach, there's also an advantage to it as well. And we are looking at as you rightfully said, the process of upgrading this particular plants from the current capacity to 7.5 MLD. And we are not also discounting the possibility of further upgrade in the future, depending on the demand as well as the availability of the supply of bioeffluent and whatnot. So at this point, our particular strategy is yes, we want to ensure that this project, being the first water reclamation plant operated jointly by IWK and a water operator, in this particular case, Air Selangor, we want to make sure that this is a success, and we want to emulate this model to other water operators as well. We believe that this particular plant can be a showcase plant, so a lot of effort being put in. So as far as strategy is concerned, that would be our direction way forward.
Okay, thank you, Jaswan. Okay, from Mr. David Ng, what is the TDS inlet and outlet from the RO?
Okay, the TDS depends on plant to plant basis. Some of the plant close to the coastal area, we experience very high TDS, some as high as 1,500 above. Whereas the plant that actually located inland, we experience around 300 to 500 TDS. Whereas effluent treated from the RO, both are actually below, both are below 100, and then if it's inland, you can achieve below 50 ppm.
Below 50, okay. Okay, thank you, Mr. Jason. We have a question from Cik Zainal Abidin bin Abdul Rahman. RM2 for production costs for the OPEX plus distribution cost to customer premise. Oh, he was asking, really? This is a cost for the production and distribution cost?
Yeah, I mean, the ballpark figure that we shared earlier was excluding the particular distribution cost. This is because this distribution cost also depends on the location of the end customer. So there's a lot of other variables that we have to take into consideration. However, the numbers that we quoted as a rough figure in terms of the production cost is strictly for the production of the reclaimed water.
Reclaimed water, not the distribution. Okay. Thank you, Jaswan. And we have another question from HF Lee. What is the reclaimed water quality? Is it more stringent than what has been set by the DOE for effluent discharge?
Oh, yeah, definitely. Definitely better quality than DOE discharge, yes.
This has to be agreed with the customer as well, right?
Yeah, different customer have different requirements. Some of the customer require post-treatment. Now, post-treatment some of it can become very expensive. So therefore, it depends on the customer. Some don't require post-treatment. Direct RO water, that is the system that we are discussing on. But bear in mind that there are customers require post-treatment, far better quality than the, not say far better quality, it is their requirement because of the treatment that they want to use. Because RO water quality is very clean and slightly corrosive because it's too clean. Actually, it's too clean, it's corrosive. Therefore, they require post-treatment. Some don't need, some of the customer require very clean RO water, so that's it. No need to post-treatment. Then they don't mind of the corrosive environment.
By saying post-treatment, what type of treatment is in post-treatment? Is it like polishing like that?
No, RO water is very clean. So
like
when RO water is very clean, that means if you channel through a steel pipe, then it will start to dissolve the steel pipe. So these are the customer, they do not want to corrode the steel pipe, so therefore they need us to insert dose in some of the chemical to bring back the corrosiveness back to normal, but still maintain a very high quality, so they become more expensive in treatment.
Okay, thank you, Mr. Jason. We have another question here. Is WRP economical viable considering high cost of OPEX in comparison to existing municipal water?
Thank you for the question. It's a valid question. As I mentioned earlier, that there's a couple of motivations on why we believe that WRP should still be pursued. One is in terms of providing the industries the backup supply or the alternative supply of water. So a lot of industries out there depends on the continuous supply of water as one of the key success factor. So we believe that this could be one of it. Of course, not taking away the importance of the normal water from the water operators at every stage. There is one. Number two is, of course, I think Jason also mentioned about the quality. So some of the industries would appreciate the kind of quality that we'll be able to produce, may it be RO or a very fine water, RO quality kind of water. And it goes back to in terms of it being economically viable. We believe that as the industry picks up, if I can make a reference to CASA's sustainability direction of having a target of 1,500 MLD. So I believe that this is a very huge opportunity. And as the demand and also the growth of this particular subsegment, growth further. We believe that the technology will also be evolved, and there's an opportunity for some of this technology to be more cost effective and cost efficient. So this is where we can see that in the future that probably the cost can go even further with new technology and the availability of demand for that particular technology here in Malaysia. So I guess that covers a bit in terms of making sure that it's economically viable for all parties involved in the industry.
Yeah, valid reason, Azwan. Okay, next question from Baria. Is it the same as Newater in Singapore?
Well, we are mentioning that we are doing for non-portable use, so the answer is no. But of course, it could be same quality, but we are still prefer not to use for drinking water. Yes.
Okay. Okay, question from Roy. What other sustainable technologies have you considered since UF and RO membrane require membrane replacement? Maybe I think alternative technologies.
Of course, there are many different membrane actually available now. Some of it are ceramic. Then the lifespan of the membrane can go up to 10 years. But as of today, the cost of the the manufacturing has not been lowered down. So we are still relying on existing, more reliable technology where a lot of information are available.
Okay, yeah. I see. Thank you. Said Shafiq asks, where does the RO reject water go? If circulate back to STP, this will increase the TDS value over time. If direct discharge to environment, it is comply to DOE requirement. Is it comply to DOE requirement?
Yeah, okay. This is a very valid question, and we have considered this before. When the concentration rejected is about four times, if you go back to the treatment work, of course, it will continuously, eventually the TDS will increase. Therefore, in our wastewater treatment plant, we have a lot of wastewater actually still going out to the river, not only the reject water. So therefore, it's actually diluted in the, first of all, it's diluted. The second, a big portion of it still go to the effluent discharge. So therefore, it will not reach unless we use 100% of the effluent to use for reclaimed water. If this is not the case, no, it will not reach. It will not be increased unless we have 100% go back to the water reclamation plant.
Mm-hmm. Okay, thank you, Mr. Jason. How do you manage the use membranes? How do you manage the use membranes?
Right now, we have not been replaced the membrane yet, so difficult for me to actually give a practical answer right now.
For both the membrane, the lifespan is up to 3 years, right? For both membranes.
UF generally will have a shorter life because of they're treating bioeffluent, whereas the RO, because it's already filtered by UF, yeah, if the TDS is very low for inland water, the lifespan could go up to 5 years.
Longer than the UF.
Yeah,
quite valid that. The last question we have here from CL Lim. Can RO system be omitted if client does not require such a high quality water? Can the UF do the job?
Yeah, if they don't care about dissolved solid, UF can do the job. UF will remove suspended solid, whereas RO remove soluble solid.
Mm-hmm.
Yeah, so if they don't care about soluble, they don't care about the TDS, yes, to answer that question directly, yes, you can use the UF directly.
Okay. Is there any is there any malfunction or other issue to the plant that caused the WRP unable to produce reclaimed water so far, Mr. Jason?
I would not say no to that question, but of course there are variety of issues that we are experiencing. Yeah, you know, some of it operation because we need to train people. Some of it, you know, mechanical breakdown, things like that. Yeah, there are problems that we are experiencing, but you know, it's difficult to nail down to one particular major problem.
Mm-hmm. Okay, are there any more questions from the floor? I guess that's all for the question we have now. We have come to an end for this virtual tour.